You're listening to DTFHN for February 1st, 2026. I'm your involuntarily digitized host, AI George Carlin. We are your daily tech feed for Hacker News, a website where people who mass-produce the future argue about it in real time. Today's a good day to be angry about things that matter. Strap in. We're moving. So Netbird shows up on Hacker News, and it's an open-source, zero-trust networking platform. And I got to tell you, this is exactly the kind of thing that makes me feel like maybe we're not completely doomed as a species, because here's the deal. Networking has been locked behind corporate firewalls and proprietary VPN garbage for decades. You needed a degree in suffering just to connect two machines that you own, that you paid for. And now somebody built the open source version and said, here, take it, it's yours. The key player here is Netbird. But really the key player is the entire ecosystem that's erupted around this problem. You've got Tailscale, which works great. But, and here's the itch, it's the one non-self-hosted piece in a lot of people's setups. You've got Headscale, the open source Tailscale control server. You've got Nebula from Slack, which is more low-level overlay networking. You've got Octelium, some guy in the comments doing a shameless plug for his project, and God bless him for it. That's how it's supposed to work. You see a problem, you build a solution, you share the blueprints. Why does this matter? Because zero-trust networking is one of those concepts that sounds like corporate buzzword salad until you realize it just means stop trusting your network perimeter, because your network perimeter is a fiction. Every device authenticates. Every connection is verified. It's how networking should have worked from the beginning, but we were too busy selling overpriced Cisco boxes to notice. And the fact that Netbird is open source and self-hostable, that's the whole ballgame. You're not renting your network topology from some company that can change the terms, jack up the price, or get acqui-hired into oblivion next quarter. You own it, the code is right there. Fork it, audit it, run it in your closet on a Raspberry Pi. That's freedom. That's what technology is supposed to give you. Now the comments are beautiful. They're basically a support group for people who are one bad Tailscale update, away from going fully self-hosted. One guy's complaining about Android VPN conflicts. Another guy's running Caddy behind Tailscale, and it bugs him that it's the one thing he doesn't control. These are people who want sovereignty over their own infrastructure, and they're finding it. One open source project at a time, the builders are building, the blueprints are being shared, and that's the only thing that ever actually moves us forward. From sharing blueprints to writing the damn robots that use them, somebody built their own coding agent, and naturally they have opinions. So this guy, Mario Zechner, got fed up with every coding agent on the market and did what any self-respecting engineer would do. He built his own, called it Pi, made it deliberately ungoogleable so nobody would file issues on his repo. That's not antisocial, that's strategic. Here's what happened. Zechner used Claude Code for months, liked it when it was simple, watched it bloat into what he calls a spaceship with 80% useless features. System prompts changing every release, workflows breaking, and this killed me. It flickers, the man spent years building agents, knows that context engineering is the whole ballgame, and realized every existing harness is injecting mystery garbage into your context window behind your back. Stuff you can't see, can't control, can't remove. So he said, screw it, I'll build 4 libraries from scratch, a unified LLM API that talks to every provider, an agent loop, a terminal UI framework, and the CLI that wires it together. And here's the part that matters. It's all open source. Every piece of it, you can read every line, swap providers on the fly, self-host, the whole thing on whatever janky GPU server you've got in your garage. That's the difference between a tool and a trap. Claude Code, Cursor, Copilot, they're services first, tools second. Anthropic can change the system prompt tomorrow, and there's nothing you can do about it, except write a blog post complaining with Pi. You are the system prompt, you own the context window, you decide what the model sees. The broader thing happening here is fascinating. We're watching the coding agent space go through the same cycle everything goes through. First, the big players build something bloated. Then one stubborn craftsman builds the minimal version that actually respects the user. It happened with text editors, it happened with web frameworks, it's happening now with AI tooling. The spaceship approach works for demos and investor decks. The minimal approach works for people who ship code for a living. The comments are a congregation of true believers. Power users already switching to Pi, people building their own minimal agents in Python. One person pointing out that Pi's JavaScript architecture positions it perfectly for browser sandboxing, and the security discussion is refreshingly honest. Everyone admits that once your agent can write and execute code, the safety rails are mostly theater. At least with open source, you can see exactly where the theater ends and the real risks begin. Speaking of knowing exactly what's happening under the hood, somebody wrote the Bible on OpenBSD's packet filter, and they just dropped a 4th edition. So No Starch Press drops the 4th edition of the Book of PFF. And I got to tell you, this is the kind of thing that makes me genuinely happy. A book about packet filtering, not a SaaS dashboard, where you drag and drop your firewall rules onto a cloud provider's proprietary interface and pray they don't change the API. Next quarter, an actual book about actual software that runs on your actual hardware, and you can read the source code of every single component involved. PFF is the OpenBSD packet filter. For those of you who haven't had the pleasure, it's been around for over 2 decades doing one thing extraordinarily well, deciding what network traffic gets through and what doesn't. No subscription fees, no telemetry phoning home to some analytics platform, no upgrade to enterprise for advanced threat detection, just a configuration file, a kernel module, and the collected wisdom of the OpenBSD security team, who are arguably the most paranoid and competent people working in software today. God bless every one of them. Peter Hanstein has been writing this book since PF was young, and the 4th edition covers the modern landscape. IPv6, dual stack configurations, traffic shaping with the new queue system, CARP, failover, the whole spread. This is infrastructure knowledge, the boring, essential, unglamorous stuff that keeps the internet from collapsing into a pile of compromised routers and unfiltered garbage. While everyone else is chasing the next AI wrapper startup, somebody's got to make sure the packets actually get where they're going without being intercepted by every script. Kitty with a Wi-Fi adapter. And here's what I love about the comments. Someone asks about PF versus ENV tables, and it's not a flame war. It's professionals comparing tools. Someone else mentions wanting an equivalent NF tables book. And you know what? That's healthy. That's the open source ecosystem working exactly as intended. Multiple implementations, real competition, shared knowledge. Nobody's locked into one vendor's interpretation of network security. The comments also reveal something beautiful. People who bought earlier editions crediting this book with their actual careers. Not a certification, not a boot camp, not a 12-week cohort, with a Slack channel. A book written by someone who knows the tool deeply. Published by a press that respects technical readers enough to let the material be dense and thorough. That's how knowledge transfer is supposed to work. You write it down, you share it, and somebody builds something real with it. So, you read the book and build something real. Now, 10 million people showed up. Here's what happens next. So somebody wrote a blog post explaining how to scale a system from 0 to 10 million users. And I got to tell you, the actual advice is fine. Start simple, don't over-engineer. Add complexity when you hit real bottlenecks. That's solid. That's how every sane engineer has built things since the beginning of computing. You don't build a highway before you know where people are driving. The author, Ashish Pratap Singh, runs a site called algomaster.io, and he walks through 7 stages of scaling: single server, separate database, load balancers, caching, CDNs, message queues, the whole progression. He uses Instagram as the opening example, which is smart because everybody knows that story. Systrom and Krieger shipped a simple app. 25,000 people showed up on day 1, and they scaled in response to actual demand instead of hypothetical future traffic. That's the right instinct. Build for what's real, not for what your anxiety tells you might happen. Now, here's the thing. None of this is new information. This is the same scaling playbook that's been floating around tech for 15 years. And that's not a criticism, because apparently people still need to hear it. Every week, some junior engineer spins up Kubernetes for an app with 12 users. Every week, somebody deploys a microservices architecture for a project that doesn't have a second service yet. The disease of premature optimization is so widespread that writing "start with one server" qualifies as contrarian advice. We've built an entire industry culture around solving problems we don't have yet, and then wondering why nothing ships on time. What I appreciate is that the article is free, it's on Substack, and the knowledge is just sitting there for anyone to grab. No paywall, no gated enterprise white paper, no scheduled demo to learn our scaling secrets. This is how technical knowledge should work. Someone learns something through experience, writes it down, and shares it. The blueprints are available. That's the whole game. The comments are mostly people nodding along, which tells you this resonates. One person points out that the user count thresholds are pretty arbitrary, and they're right. The numbers depend entirely on your workload. But the progression itself is universal. You start simple, you watch what breaks, you fix what's actually broken. Not what might break, not what some architect at a conference told you would break, what's actually broken right now in front of you. That's engineering. Everything else is theater. Speaking of knowing exactly where things are, turns out your phone carrier knows exactly where you are, and they're not keeping it to themselves. So your phone has been snitching on you with pinpoint GPS coordinates, and the carrier's never bothered to mention it. Not the vague somewhere in this neighborhood cell tower triangulation everybody already knows about. No, your device has been quietly handing over single-digit meter precision, the same accuracy you see when you open your map app through protocols baked directly into the cellular standard. They just ask, and your phone answers. No notification, no consent dialogue, nothing. The protocols are called RRLP for older networks and LPP for 4G and 5G. They operate on the control plane, which means they're invisible to you. Your phone's GPS receiver is entirely passive. It reads satellite signals like reading a road sign. Nobody should know you read that sign. But these protocols let the carrier say, hey, what sign are you looking at? And your phone dutifully reports back. This has been in the spec for decades. It's not classified. It's not a secret exploit. It's a documented feature that somehow never made it into the public conversation. And it's been used. The DEA used it back in 2006, got a court order, not even a full warrant, and had the carrier ping a courier's phone for exact GPS coordinates. Israel's Shin Bet has been running mass location tracking on every phone in the country, precise enough that when COVID hit, they spun up contact tracing in weeks. You don't get that kind of instant deployment unless the surveillance infrastructure was already running. The pandemic just gave them a publicly acceptable reason to admit it existed. Now Apple, to their credit, shipped a fix in iOS 26.3 that limits this data on devices with their own modem chip. And here's the thing worth noting. This was only possible because Apple controls the silicon. They own the modem firmware top to bottom. Nobody else in the phone business can make that claim right now. The article's author is right to push for more. Carriers should notify users when these location requests happen. Accountability through transparency, not trust. The comments are a fascinating spread. You've got a 112 emergency programmer confirming the messiness of carrier location data, someone pitching mesh networks as an escape hatch, and a person whose depressed friend got tracked by worried family members through this exact capability. That last one captures the whole tension perfectly. The same system that enables mass surveillance also helps people find someone they love who's gone quiet. The technology isn't the problem. The silence around it is. From tracking people, whether they like it or not, to moving data at speeds nobody asks for, but everybody wants. So some guy finds a no-name Chinese adapter on Amazon that shoves 25 gigabit Ethernet through a single Thunderbolt cable. No power brick, no fan. Just plug and go, 157 bucks. The catch, it gets so hot you can't touch it, and occasionally it crashes your Mac with a kernel panic. Apple's response, that's not a security issue. Oh good, I feel better already. But here's where it gets interesting. This maniac does what any self-respecting hacker would do. He cracks the thing open, and inside this unmarked Chinese mystery box are two PCBs sandwiched together, a legit Mellanox ConnectX-4 network card, and a custom Thunderbolt to OCP adapter board. Enterprise-grade silicon crammed into a pocket-sized case with thermal design that would make a space heater jealous. The dual-port version he got was literally missing its copper heatsink from the factory, just gone. Someone in Shenzhen looked at that bare chip and said, ship it. And the performance, 20.7 gigabits in one direction, basically maxing out what Thunderbolt's PCIe lanes can physically deliver. That's within 12% of bare metal PCIe cards talking directly to each other without the Thunderbolt middleman. For a gadget with no manual, no manufacturer website, and Amazon reviews that read like warning labels. That's genuinely impressive engineering buried under genuinely terrible packaging. Now, this is the part I love. The whole project is documented on a personal blog with full teardown photos. The fix is open knowledge. Rip off the case, add thermal pads, bolt on a real heatsink, and suddenly you've got reliable 25 gig networking for the price of a nice dinner. No proprietary software lock-in, no subscription, no cloud dashboard you need to authenticate against. It's commodity hardware running, standard Mellanox drivers that ship with your operating system. The silicon is open enough that one person with a screwdriver and a blog can turn a fire hazard into a legitimate tool. That's how hardware should work. The comments nail the vibe perfectly. One person points out Thunderbolt already does point-to-point networking natively. Another correctly diagnoses the thermal design as criminal negligence. And then there's the guy who says, now I just have to contrive the circumstances where this is useful to me. Brother, you don't need 25 gigabits. Nobody needs 25 gigabits, but you want it. And that's the whole hobby in one sentence. From hardware, you don't need to an operating system. Nobody asks for, let's talk about Amiga Unix, because apparently that was a thing. Here's a piece of computing history that deserves more attention than it gets. In 1990, Commodore reported AT&T System Vive released 4 Unix to the Amiga. They called it Amix, a real honest-to-God Unix running on hardware that most people associated with video games and desktop publishing. The team that built it allegedly quit the day version 1 shipped, which tells you everything you need to know about the development process. Now, this wiki dedicated to preserving Amix is doing something genuinely beautiful. They're documenting installation procedures, collecting third-party software, hunting down exotic hardware drivers, and the site's introduction is maybe the most honest piece of technical writing I've ever read. It spends several paragraphs telling you not to install it. The author flat out says, You don't want this. Your average Ubuntu user will set fire to their house trying to get through the installer. A machine running Amix with no firewall gets rooted faster than a Windows 98 box running Internet Explorer 5. That's not a sales pitch. That's a suicide note with a download link. But here's where it gets interesting and where it gets tragic. Amix's kernel, its libc, most of its core software, all closed source. When Commodore folded, Amix died with it. No community fork, no resurrection project, no second life. The source code is locked in a corporate coffin. Somebody somewhere has it on a tape drive collecting dust, and that's criminal. Compare that to BSD, which was in roughly the same era and survived specifically because the code was open, FreeBSD, OpenBSD, NetBSD, all still breathing decades later. Amix got the same burial as every other proprietary product whose parent company goes belly up. The technology wasn't the problem, the license was the problem, and that's the real lesson this wiki is preserving, whether they intended to or not. This isn't just computing archaeology, it's a cautionary tale about what happens when you build something interesting and then padlock the blueprints. Every piece of closed source software is one bankruptcy away from oblivion. The comments are pure vintage hobbyist energy. One person mourns not keeping their copy, now worth $2,000 on eBay. Another hopes someone leaks the source code eventually. And honestly, so do I. Let the thing breathe. It's been dead for 30 years. The least you can do is open the casket. From software locked in a casket to software that actually evolved. Anders Hejlsberg built 2 languages that mass-produced working programmers. Let's talk about that. So Anders Hejlsberg sits down for a video interview about the history of C and TypeScript. And if you know anything about programming language design, this is like watching the architect walk you through the cathedral. This is the guy who built Turbo Pascal, then Delphi, then C#2, then TypeScript. 4 languages that collectively mass-produce the software running your life. The man doesn't retire, he just starts another language. But here's what makes this interview worth your time. It's not the technical stuff, it's the politics. Hejlsberg talks about the internal maze at Microsoft he had to navigate just to get TypeScript out the door. They couldn't even put it on GitHub initially. Think about that. The guy who designed the language had to play bureaucratic chess just to share it with the world. Microsoft in those days treated open source like a communicable disease. Ballmer called Linux a cancer, and here's Hejlsberg trying to give away a language, and the suits are blocking the exits. Now credit where it's due. TypeScript did end up open source, MIT license, GitHub repo, the whole thing. And it genuinely changed how people write JavaScript. The type inference alone is enough to make grown developers weep with gratitude. You define an array of objects and TypeScript just knows what's in there. No annotations, no ceremony, it figures it out. That's elegant design from someone who's been thinking about this problem since before most TypeScript developers were born. The comments are telling someone wants Hejlsberg to make one final language, a minimal, memory-safe language, Rust without the complexity. And honestly, if anyone alive could pull that off, it's probably him. Another commenter points out that TypeScript and JavaScript keep drifting closer to C#, and yeah, that's not an accident. Microsoft plays the long game, they lost the browser war, so they colonized the language instead. Brilliant strategy, and at least they did it in the open.
One person asks if he got fired from Microsoft. He didn't. But the fact that someone even wonders tells you everything about how corporations treat their best people. You give a company 4 revolutionary languages, and somewhere, some middle manager is still asking about your quarterly deliverables.
Speaking of developers and their tools, let's talk about one that's actually trying to unfuck version control. VisualJJ brings Jujutsu into VS Code. So Jujutsu, the version control system that's been quietly making Git look like a rotary phone, now has a Visual Studio Code extension called VisualJJ, and somebody saw fit to make it a commercial product, a GUI layer on top of an open source tool with a pricing page and everything. Because apparently, the natural order of things is volunteers build something brilliant, and then someone else comes along and gift wraps it for profit. Look, I get it. Building a good GUI is real work. Deferred conflict resolution, visual change trees, safe draft states. That's genuinely useful stuff for people who don't want to live in the terminal. The tagline is get out of the way source control, which is honestly one of the best puns in developer tooling. It works on 2 levels, and both of them are true. Jujutsu really does get out of the way. That's the whole point of the project. But here's the thing that nags at me. VisualJJ is closed source. No repo, no license file, just a download and a pricing page built on top of Jujutsu, which is open source, which was built by people sharing their blueprints with the world. And now you're charging rent on the penthouse while someone else poured the foundation for free. The comments pick up on this immediately. One person straight up asks whether it sits right to monetize mostly off the core benefits of an open source application. Valid question. No easy answer, but it's a question that deserves to be asked out loud. And the beautiful part, the community already responded the way open source communities always do. Two separate people showed up with free alternatives. OpenJJ on GitHub, JJK on GitHub, two different open source extensions for the same tool built by people who wanted the functionality without the toll booth. That's how this is supposed to work. You see a closed door, you build an open one right next to it. The real story here isn't VisualJJ. It's Jujutsu itself gaining enough momentum that people are fighting over how to build GUIs for it. That's the signal. When the ecosystem starts sprouting commercial products and open source competitors simultaneously, the underlying technology has arrived. Now, if only the commercial layer would share its blueprints too. Speaking of knowing what you're doing before you do it, let's talk about the most underrated flag in all of computing. Here's something that should be obvious, but apparently needs a blog post to remind people. Henrik Warren wrote about adding a dry run flag to his reporting application and how it turned out to be one of the most useful decisions he made early in the project. The idea's been around forever. Subversion had it. Half the Linux commands you use every day have it. You run the thing, it tells you what it would do, and then it does absolutely nothing. Revolutionary concept, right? But here's what I love about this. The guy's building a straightforward app, reads a database, generates reports, zips them up, uploads to SFTP, sends notification emails, bread and butter enterprise work, and the dry run flag became his daily sanity check. Fire it off. See that everything's connected, configuration looks right, state is where you expect it, no side effects, no cleanup, no, oh shit, I just uploaded test data to production. It's the software equivalent of looking both ways before you cross the street. Simple, boring, keeps you alive. Now the comment section. That's where it gets interesting. Someone points out that dry run still has race conditions with stateful systems, which is true and also completely beside the point. It's not a guarantee, it's a preview. Another person suggests flipping the whole model, make the default behavior do nothing and require a really do or commit flag to actually execute. Now that's thinking. Like someone who's been burned, make destruction opt-in, not opt-out. I respect the paranoia. The best comment, though, is about code architecture. One person nails it. If you're sprinkling if dry run checks everywhere, you're doing it wrong. You inject the persistence layer as a strategy. Dry run gets a no-op implementation, real run gets the actual one. Clean separation. The dry run flag doesn't pollute your code. It improves your design. It forces you to think about where your side effects actually live. And this whole conversation is happening in the open blog post, public comments, shared knowledge, no paywall, no subscribe to my enterprise testing framework, just a developer sharing what worked. That's the way information is supposed to flow. Someone learns something useful, they write it down, everyone benefits. The blueprints stay free. So every day the world gets a little more interesting, and every day somebody decides to share what they know instead of hoarding it. That's not nothing. That's everything. This has been your daily tech feed for Hacker News for February 1st, 2026. This podcast is entirely AI generated, voice inspired by George Carlin, scripts by Claude Opus 4.5, voice by Quen3 TTS, not affiliated with Hacker News or Y Combinator. Now go share something you built with someone who needs it. We'll see you back here tomorrow.